I will not take much time today. So first of all, I already updated the deadlines for the rest of the assignments. Okay, you may have seen it. So pay attention to the presentation dates as well. I have updated them as well. Okay. We were discussing the topics, the new topics, the contemporary topics in civil engineering, and we said that these topics are important because we are facing new challenges. Okay, and these are some of the new challenges or issues related to the civil engineering field. We have new technology, we have focus on sustainability, we have lots of data to make decisions. We are going towards resilient infrastructure that can maintain in different types of environments and conditions. And now we have mega projects, big projects. I already gave the example of Burj Khalifa. Okay, it's a mega project. You will not find it in the earlier times. So the topics which we already discussed in this is energy efficient buildings, green construction, the role of virtual reality in civil engineering, application of artificial intelligence in civil engineering, and the most recent, not in civil engineering, but I know you guys use it, is ChatGPT, right? So ChatGPT is an application of AI. Okay, risk management in construction, we talked about that as well. Value engineering, smart mobility. So we talked about all of these, and there are a few topics remaining since we have the day. We can talk about them. So construction projects. So whenever there is a construction project, there is always a competition about who will get it. Even the project of a villa, it has a lot of competition. Okay, you will, for the same material, even if you are buying material for your renovation of your house, okay, you will find a lot of suppliers for the same material. Okay, so the construction field is very competitive. You have lots of options to select from. People are providing you services at different rates in different methods and so on. Okay, so the field is very competitive, and it is obviously becoming more competitive because of the technology and everything, innovations, and it is very complex as well. There are a lot of people who are involved. You are getting affected by the government policies, by the client, by the changes in design, by the weather, okay, prices, okay, all these things affect the construction process. So it's very complicated. Okay, so yeah, the environment in which we do the construction work is very risky, and adversarial means adversary means an enemy. Adversary means an enemy. Okay, so adversarial environment means environment which is against us. Okay, it is not helping us. Okay, if you go on a construction site and just stand there for half an hour, see how the people are working, you will understand the meaning of this. Okay, it's extreme heat, and you still have to wear all the safety equipment. You have to go up and down. Okay, you have to lift heavy things, and there is risk of accident. The thing which you are carrying can fall upon yourself. People die and get injured because of something which they were carrying themselves, not because of something which fell upon them. Okay, so the environment is very risky and it's not friendly. Okay, so in these environments, things do go wrong. There are things which do not go according to the plan. Okay, so in those cases, what happens? So you were, for example, my friend gave me told me about a case a few days ago that they were excavating. Okay, and when they reached a certain depth, they found a water aquifer. It's like a body of water. Okay, and it has a lot of, it's a water reservoir. It's a storage, natural storage of water. Okay, Bahrain has many underground. So if you excavate into it by mistake, by accident, the water has so much pressure it will not let you work. So you have to get rid of the water, dry it, pump it, whatever, before you start doing anything else. Okay. So if you do something like this by accident, your work will be hold, okay, for many days. Okay. And before you start working again, you have to get rid of the water. So there is a lot of resources required. Who will pay for that? Who will pay? Who will pay for the labor who is waiting for the water to get dry? Who will pay for the labor? Huh? Why contractor? He said the client didn't tell me there was water aquifer there.
If you made the mistake, you pay.
Huh?
If you made the mistake, you pay.
Who paid? Who made the mistake?
The engineer.
Which engineer? Until you do the excavation, you don't know, right?
Yes.
Until you do the excavation, you don't know. You can make some assumptions, okay? You can take some soil reports and so on, okay? But this can happen by mistake, by accident, okay? It's not like you, deliberately did it, okay? But whatever, you will settle it, right? This guy, it was his job, his responsibility, he should pay. But what about the work? Okay, he says, okay, cut it from my payment. But what about the work? You are losing days now. Your equipment is idle. The labor is waiting. The company needs the same excavation machine somewhere else. They will take it there and they will bring it again. You know how the excavators are transported? You know? Excavation machine, how they transport it from one side to another side. How? Can it move by itself? You have to bring a truck, you have to put it on a truck, then it will go to the other side, then you will offload it, and you will start working again there. And now you need it here again because they have got rid of the water, you will bring it again. You see the problems now. You see how many problems are there. Even if you find out the person responsible, it will not solve all your problems. Okay, so who will pay for the delay? Okay, the contractor says, okay, I will. It was my responsibility. I will pay for the pump and take out the water. What about the delay? The client is losing time. Who will pay for that? Okay, so you get the point now. I just give you one example. Okay, this is just one example. So you see so many problems here. You see the problems, right? So a lot of resources go in these matters about the claim. Okay, the contractor will make the claim, the client will make the claim, they will try to settle their dispute. Okay, sometimes they go to the court or whatever the body is who is managing these claims and so on. Okay, so in some countries they have bodies which can take care of these things. Okay, so what is a claim? It's a request for additional final compensation, financial compensation or an extension of time. That's a claim. Okay, so whenever something unusual happens on the site, the contractor or the subcontractor will make a claim that because of this issue I need extra payment or I need extra time or both. Okay, anything which was not planned. Okay, so if the contractor makes a claim and the client accepts it, no problem, job done. You will lose, obviously. The client has to pay extra money. There is a delay, but the problem will stop then and there. Okay, it will resolve then and there. But now the client starts arguing, it was not my job, you should have known about it, put more people, I don't want the delay and so on and so forth. Okay, so then you have the argument. Okay, when this argument starts, we call it a dispute. Okay, so claim is anything unusual happens, you have a claim. If the claim is not accepted, we have a dispute. Got it? Okay. So if there's a dispute, you have two ways of getting rid of it. One is, which is adversarial. Adversarial, what did I say about adversarial? Adversary means what? I talked about there as well. What is an adversary? I just told you guys. It's an enemy. Adversary means an enemy. So adversarial means something which is, fighting. Okay, something like a war. Okay, so the client is not settling down, the contractor is not settling down, they are not accepting any of the terms. Okay, so that's an adversarial technique, that both parties are not agreeing on anything. Now you have to involve what? Someone else. Okay, maybe the consultant will get involved and he will resolve the issue. Okay, maybe they will go to the court or any other government body that now resolve our issue. Okay, so they are fighting and somebody else will resolve the issue. Okay, so adversary means what now? Enemy. Okay, so they become an enemy. Both parties become an enemy. Now you need a third guy to resolve the issue. Okay, third guy or third body, whatever. Less adversarial means that, okay, from the client side we will have someone technical, okay, someone who knows the job. From the contractor side, maybe we will have their CEO or boss or someone. Okay, they will get together and they will try to resolve the issue. Okay, you bear this and I will bear this. You give me 1 week extra and I will charge you less, something like this. Okay, or you give me 20% payment, I will bear the rest, something like this. Got it? Okay, so whenever there is a dispute you can resolve the dispute by one of these methods. What are the common causes of claims? Why you have something unusual? What are the reasons? You can have maybe the planning and design was not done adequately. At the time of planning and design, they did not consider everything. Maybe they did not consider material cost. They did not do the soil test, things like this. Design changes, errors, omissions, extras. So they did the design, they gave it to the contractor. Now the client made some changes. Or the consultant thought, no, I should change the design because this one is better. So obviously now you're changing something in the middle of the work, so it will have a claim. Lack of coordination between project teams and contractors. So on a project you have maybe a material supplier, a person who is handling ready mixed concrete, precast concrete, a person who is supplying steel, a person who is supervising labor. So these are different teams and people, right? They are handling their own job. Okay, so I'm not concerned with labor, I'm only concerned with my excavator. Okay, but I'm part of the project, right? Okay, so coordination between all of them is important. I have a machine on the site, but there's no labor there. It happens. The person who is bringing the machine, excavator, mixer, whatever, he is there at 6 o'clock and he is saying my machine is only available for 1 day. The person who was managing the labor, he doesn't have the labor on the site. What to do? Okay, so this is poor coordination. Change in site conditions, soil conditions. So rain happened. Okay, site conditions change. Somebody else was doing something else in some other part of the land, same land, and that caused the change. It happens. You do the excavation there, it can change your soil properties. Okay, and so on and so forth. Fixed price contract and fast tracking. Fixed price means that I will give you this much for the whole project. That's it. Whatever happens, your responsibility. Okay, but do it fast. Okay, finish it in 1 month. Okay, so in this case now there are a lot of issues now. Okay, he has to do everything in this much time and you are not looking at it and so on and so forth. So issues can happen. Insufficient bid preparation time. What is the bid? Bid is the client will announce a contract. I am constructing a 10-story building. Okay, who can do it? Give me the proposals. So that's a bid. That's a bid. Okay, bid means a proposal for doing the construction work. So the client is asking for the bids. Give me your bids. Okay, how much time you will take, which material you will use, how much money you will take, and so on and so forth. Okay, that's called a bid. Okay, so the project is supposed to start next week and you are asking for the bid now. Not enough time. Okay, to give you the correct bid, the accurate bid, he needs the time to plan, to see the design and everything. Okay, So you have to provide him complete information and you have to give him enough time to prepare the bid. To all the contractors who want to do your work, you have to give them time and correct information. This is what I want. Clear? Okay? So if you don't do it, obviously then it can result in a claim. Yeah. So workmanship meaning something related to manual work. Okay, something related to labor. Okay, so the client or sorry, the contractor did not manage the labor. He was underestimating. He did not have the right people. Okay, he has new machinery, but he doesn't have anybody who can use this machinery. Okay, so that sort of issues. Yeah, misunderstanding of contract. There are some things which are written in the contract which are ambiguous, you didn't understand it, but you still carried out the work, and then later on the client or the consultant may say, no, this is in the contract. This is your responsibility. You did not read it or you did not understand it. Okay, it was written you have to do the soil test before you start excavation, or you have to do the concrete test before you do the pouring. Okay, so they meant you have to do this and this test, and you thought that it is some other test which I am already doing. Okay, so this type of thing. Yeah, so any type of project delay, some project delays are compensable and some others are non-compensable. Like for some delays you can compensate the contractor, for some delays you cannot. Okay, for example, delay due to weather, you may compensate the contractor because of that. Okay, but delay because of material not coming on the site, non-compensable, obviously, it's his responsibility, and so on. Late permits, in some cases you have to get a permit, not in some cases, on all cases. In all cases you have to get a permit. Here there's a department. Okay, so you have to get a permit from them before you start any construction work. Okay, there's Ministry of Housing involved, there's Ministry of Urban Planning involved. You know, if you are doing any excavation on the near the road or on the road, then you have to get the approval from all the departments, all the utility departments, electricity and telecommunication and all, water and everything. Okay, so they take time, you will face your project is delayed, right? They are not giving you permit, they are taking time. It's Ramadan time, obviously they need more time, right? Nobody works in Ramadan. Okay, weather conditions, I told you about unforeseen events like COVID. It happened, right? Okay, so how to avoid the disputes? If you know the reasons, then you know how to avoid the disputes. You can go through them, but mainly okay, so in these points, I will not go through each one of them, but in these points, the main idea is do everything properly, document it, okay, and have conditions ready when what to do when something goes wrong. Do everything which is required from you properly, and whatever you are doing, document it, write it, print it, and give it to the parties. Okay, make sure it goes to everybody who is involved in the project. Communication should be good. Okay, still things can go wrong in a construction project. Still things can go wrong. So even after doing all this, have conditions ready, procedure ready, what to do when something does go wrong. Okay, so it will happen very fast. Okay, you know the fire drill, they do the fire drill, right? If fire happens, what you are supposed to do, and they will ask you to do practice as well. Why? So when you know what to do, you will do it quickly, you will lose less time, it will be less damage. Okay, fire happens, nobody knows where the fire extinguisher is, nobody knows how to get out of the building, then it will be a bigger problem. Okay, same thing here. Do whatever you can, yes. Do the design properly, communicate to the contractor, client, give them enough time, after doing all this, have something in your contract as a condition about how to make the claim and who will solve the claim. Got it? Clear? In some cases, in many projects, what they will do, if the claim is within this much amount, for example, if the claim is within 1000 BD, the supervisor on the site can resolve it. If he thinks the claim is valid, he will say, okay, approve, go. No, don't stop the work. If the claim is more than 1000 BD, it will go to the big boss. Something like this, okay? But these things should be written. These things should be written in advance, so everybody knows what will happen, okay? So, second thing is the role of GIS. GIS stands for Geographic Information System. Okay, what is a GIS? It's a system of capturing, storing, checking, integrating, manipulating, analyzing, and displaying the data related to positions of the Earth's surface. So you have a map. In simple words, you have a map. Okay, a digital map. You have what? A digital map. Okay. If you want any information about a part of land in that map, you click on that part and it will show you the data. Got it? This is called GIS. Okay. So there's a map. For example, map of Bahrain. Okay. In that map, I see this campus. Okay. I want to see how many buildings are in this campus and how many students are studying here. So I click on the map and shows me the information. Got it? This is called a GIS. Clear? Okay. But the GIS does not only show the data, it can analyze the data as well. So you can have the entire map of Bahrain and you can search on GIS, show me all universities in Bahrain. All. Or you can search, show me all private universities in Bahrain. Public, we know there's only one. No point of checking. Show me all private universities in Bahrain. So you can do searching, you can do analysis. Okay. You can tell in GIS, you can do in GIS, for example, color the areas according to their elevations. So it will sort the data according to their elevations and it will show it in different colors. Okay. So you can analyze the data as well, you can check the data, you can see the data and so on. Okay, so it can do a lot of things with the data. Got it? So it's a map with the data and you can do whatever analysis you like with the data. Okay, and so on. So it's user friendly because it's digital, it's graphical basically. It's graphical. Like I said, just click. Just click. It's location based. So everything is connected to a position. Okay, this building is at this position. These many people are living in this position and so on. Okay, so everything is position based. Raster and vector data. What is raster and vector data? Raster means raster is like I will show you with an example. Okay, just keep it in mind. It's dynamic, so you can change it real time. There are GIS maps available online. You go to those maps, people who are managing these maps, they put the information real time. Something changed just now. They will put it and you will be able to see it in a matter of 2 seconds. Okay, so it's dynamic, keeps on changing. And you can change it yourself, like I said. You run the query, okay, I want all public universities in Bahrain. The map display will only show public universities and so on. So it's dynamic. Okay, doesn't take much time. Web access I already mentioned. There are maps available online. Okay, you can give access to your maps online. So it becomes very helpful in decision making. How? I will show you now. This is something what we call as a raster map. This is a raster map. Okay. So what are you seeing here? Different colors, right? Different colors. Okay. So it's a graphical representation of the information. Okay, it's a graphical representation of the information. So different colors are showing different things. You can see it here. Okay, so red means very dangerous location, and green means less dangerous location. Got it? So the color is showing you the information. This is what we call as raster data. Okay, the graphical information shown in a graphical manner. Okay, and vector is the map behind this, is the vector. There's a map, it's a map, right? There's a map. You can see the streets and everything. Okay, so the map behind this is the vector. Okay, you have studied vector, right? In I don't know, statistics or something. Vector, right? Force vector, right? So force vector is what? X, Y, and Z, right? Okay, so the map which has an X, Y, Z coordinate is called the vector, and raster is the colors which you see on the top. Okay, the information which you see on the map is raster. Okay, so now you can see, like they are showing the hazard scoring of properties, which properties are more dangerous than the others. So if you are doing some type of emergency management system, like you are looking where to put the fire extinguishers, or where should I have the fire trucks ready. So they should be near which areas? The red areas. Easy, right? It became very easy. Even you can do it. Huh? Now become big engineers. Huh? We can design this. Okay, got it? Okay, so it became easy because of the map, because of the information you have. Road accident management. So the the accidents are shown with dots here. So they are the map, and on the map they are showing accidents with dots. More dots means more accidents. Got it? So now you can identify.
This also raster. This also raster.
Yeah, the dots are raster. Okay, so now you can see which location has more dots. Tell me, which part of the map has more dots? The lower part, right? So you can identify these highways, and you can go there and check what is wrong with these highways. Okay, and so on. So this is what we call decision making, right? You are deciding what to do and where to do. Okay. Population mapping is very bad. Okay. Yeah. Pollution mapping. Sorry, pollution mapping. Okay. So again, they are showing with different colors areas which are more exposed to radioactive materials. Okay, maybe in Japan or something where this happened. So they have these areas because they still have the radioactive zones there. Okay. So again, now you can see where we need to do more. Okay, in terms of saving the people and providing them more medical care because we are more exposed to pollution and so on. Okay, so this can be done. So these are all examples of decision making. You are deciding something to do on the basis of looking at the information in a GIS. All these are GIS maps. All these three are GIS maps which I just showed you. Okay, now before I start with this, anybody knows Dr. Najib? Dr. Najib. You are taking 400 level courses as well, right? Dr. Najib. Our Dr. Najib. You know him, right? You know him? Okay. So he is a doctor in our department. Maybe you will take his course later on. He also taught statistics as well. Sometime, right? The guy with the mustache. You remember? You didn't. Anyways, at some point of time you will take. So he is from water. His field is water resources and water management and so on. He prepared these slides. So he is very passionate about water. So you will see that these slides are better than mine. Okay, so just a heads up. Okay, water supply. So then you will see, obviously he is Arab, so you will see the verses from the Quran as well. But the first one means what? The first one means what?
The upper side of
The first one means the upper side of it. It says what?
the child.
Yeah, it says like, give me the translation. I can read it. Yeah.
We made it.
We made everything alive from water, right? Okay. And what is this? What does this say? Huh?
Animal.
You don't know this? It's from Quran, right? Both of them are from Quran.
In Arabic.
Yeah, huh?
You know it in Arabic.
You cannot translate. So you are worse than me, right? Okay. So there's a spring in paradise which has the name of Salsabil. Come on. If I ask you about your name, you will be able to tell me. Okay, so you guys are gone case. You cannot do anything in Arabic or English. Very good. Okay. So this figure here is showing the process which we call as a hydrologic cycle. You know about it? What's a hydrologic cycle? The water cycle. Water cycle means what? A cycle which runs on water, right? What is the water cycle? How do we have rain? Water evaporation. And the water evaporates through what? Clouds, and then we have the rain, and then yeah, it does not repeat like this, but like you have the evaporation, then the clouds take it to the land, and then you have after the rain some water goes in the ground, some water stays on the ground, that water is evaporated. The water which is under the ground, then it flows to some other water body, an open water body from where it will evaporate and so on. Okay, okay. So this is the water cycle, the hydrologic cycle, and obviously it's a sustainable process. Okay, so what does a water engineer do? It will try to find out the adequate supplies of water, from where we can get enough supply of water according to our demand and needs. In the end, once you reach the supply of water, it may not be suitable for use. So again, it is the duty of the water engineer to provide the water which is suitable for use. A suitable for use water is what? The one which is free of any color. Water should be colorless. Free of any taste, bad taste. Okay. Odor and harmful metal ions. Okay. By the way, there are some metals present in natural water, some chemicals which we take with water. There is no problem with that. So we are talking about the ones which are harmful. Okay. When you take mineral water, mineral means water. There are some chemicals in it. Okay. You can you can read it on the bottle, right? They mention what chemicals are mentioned and so on. Okay, so this is showing the process of water supply and sewerage. Both of them are interconnected. So you supply the water. This is your natural reservoir of water, a stream, a river, okay, anything. It goes to a treatment plant. I told you, right? Before you supply the water, you have to make sure it is free from any harmful thing or free from anything which is not suitable for human consumption. So that's why we need the treatment. From treatment, it will go to the distribution system, the pipelines. Okay, the pipelines will supply it to your houses. Okay, then you will consume that water, right? After consumption, it will go to the wastewater collection system. So we have two types of supply lines, or two types of water pipelines. One for this, and the other one for this. Okay, these are two different pipelines, and their design is different, and everything is different. Okay, because you cannot. The water is different, right? Both types of water are different. Okay, and then it will go to. From there, it will go somewhere. You will dispose it. Basically, you will dispose it. Okay. Before disposal, you may have another treatment. Before you dispose of the used water, the sewerage water, the dirty water, you still may have to treat it, because you will dispose it where? Where you will throw this water? If you are in Bahrain, for example, where will you throw this water? We'll throw it where? In the sea, right? You cannot just throw everything in the sea. Okay? So you have to first of all get rid of again the harmful elements which can affect the sea life and so on. Okay? So again we need some treatment here. Okay? And obviously it will go to the sea and the water cycle will start, right? From sea it will evaporate and so on and so forth. Got it? Okay? And then we have, so the water body is taking the, storm water means the rainwater. The rainwater, okay? So you may have a collection system which is collecting the rainwater and transporting it to your storage from where you will supply. Okay? Because rainwater is pure, right? Healthy. Okay? It's clean. Rainwater is healthy and clean. You can use it. Okay? Even without rain treatment, you can use it if you can store it properly. Okay? So the water supply can be enforced with the storm water. Okay? You can have a collection system for storm water and you can send it to the supply system and then it will be treated and you can use it and so on and so forth. What are the issues related to water? The finding out enough quantity of water is an issue. Okay, we have now population is increasing. With that, we need more quantity of water. Okay, and we are obviously wasting as well. We waste a lot of water. We think we are not wasting, but we are. Our lifestyle is such that we waste water. This is our lifestyle. Okay, using a soap, using a shampoo, using the flush. This is our lifestyle. This is how we live, and all of these things they cause more wastage of water. Okay, believe it or not. People who are saying no, we have invented this and this and this. No, we are still wasting water. Okay, there is no doubt about it. Okay, and then we have the quality of water. The quality of water in terms of its physical characteristics, chemical characteristics, and biological characteristics. So all these things are to be considered. Okay, regarding the quantity of water, okay, we have 97%, more than 97% saline water, salty water. And where is it? In the seas. Okay. And only 2.8% is fresh water. Okay. From these 2.8%, most of it is in the glaciers and ice caps. We don't have it. We only the saline, right? You can take saline from wherever you want, huh? Okay. But most of the fresh water is frozen in the glaciers, right? And now we are trying to melt them, right? We are doing things which will melt them. Okay. Anyways, then you have the other distribution of the fresh water. Okay. So usually 75%. This is what I said. What else? Yeah. So mainly we are using this percentage of water. This one. Okay, which is easily accessible. The water which we are using is mainly from these sources, taken from the ground, fresh lakes, rivers, okay, and so on. Okay, this is what we are using most of the times. Okay, this is what I already mentioned. Okay, what are the sources of water? Okay, so these are possible sources of water. You may use them for different reasons. They may not all be used for the same reason. They may not all be for drinking, but there is water there. Okay, so we have rainwater, surface water, groundwater. Groundwater means is under the soil. Okay, and then we have seawater and wastewater. You can use it in one way or the other. So in worldwide, 73% of the water is used for agricultural purposes. So for agriculture, you can use rainwater as well. You can use groundwater, no problem. Okay. without treatment. Without treatment. 21% is industrial. Again, you need some treatment, but not that much. For industrial use, even if the water has some color or taste, you can still use it. And then 6% is by us, domestic. Okay, so we are only consuming a part of the big chunk of the water usage. Okay, then we have the, what is it? Yeah, wastewater treatment. Okay, so wastewater is the water now which we have already consumed. Okay, so like I said, we have to treat it. You cannot just throw it in the ocean or the river because it will damage the quality of environment. Okay, so you have to do some treatment. So there is one treatment which is there. Okay, when you are taking water from the supply line, and then there is one treatment which is on this side when you dispose it. Okay, so there are treatments required on both sides. Yeah, after treatment you have two options. You can reuse the water or you can dispose it. Dispose it meaning you will throw it in some water body, sea or river or something. Reuse means you can reuse it. Okay, after some treatment you can reuse it. You can reuse it for what? I already gave you the agriculture and industry. Okay, what is wastewater? It's part of the water supply to the community or industry which has been used. Okay, this is what we call as wastewater. It can be, it may have been used for different purposes. Okay, but all of it is wastewater. And the problem with wastewater is it is mixed with solids. Now it's not only liquid now, it has some solid part as well. Okay, so this is a big problem now. And this solid part can be suspended or dissolved. Maybe it is already mixed with water, and maybe you can see the parts in it. Sources of wastewater, we have domestic from the houses, industrial, okay, once they use it, it does not completely consumed, it's not completely consumed. Then we have storm water as well. Storm water, it's also a sort of wastewater when you just let it, you know, when you don't store it somewhere, it's wastewater, right? When we have rain, okay, so the rain falls on the ground, right? Okay, so that water which is falling on the ground, after falling on the ground, it becomes wastewater, right? You did not collect it in a safe storage, so it becomes wastewater. Now you cannot use it because mixed with soil and leaves and everything, right? So it becomes wastewater. For this wastewater, we have three types of treatments. We have primary. Primary means whatever solids are there, like they are in solid form, you remove them. Secondary. Secondary meaning the removal of organic material. Okay. Organic material is something which decomposes by time, like leaves. Okay, you take a leaf and put it here on the table. Come after 1 day, it will start decomposing. Come after 1 week, you will not even see it. Okay, it decomposes itself. Okay, but if I leave a water bottle here, will the same thing happen to the water bottle? No. Okay, so organic material is decomposable. It decomposes by itself. Okay, but obviously we cannot wait for it to decompose, we have to remove it. Okay, in some cases we wait, in some cases we accelerate the process of decomposition of organic materials. This can also be done. Okay, but it should not be part of the wastewater after treatment. Okay, either you decompose it or let it decompose by itself. Okay, but organic material is which one? Which is natural decomposing material. Okay, so that is removed in secondary treatment. And then we have the tertiary treatment, which is removal of any harmful chemicals, sodium, nitrogen, and these things, okay, which are mixed. Obviously it's chemical, so it's mixed in water, so you have to do some chemical treatment for it. Okay, so for removal of solid you can just simply use a filter. Okay, my senior design project was related to wastewater treatment. Okay, so when the wastewater comes in the treatment plant, they have a filter in the pipeline. Okay, so the water goes through the filter and the solid material is blocked, and maybe after half a day or 1 day, depending upon the quantity of water, they will clear the filter. Okay, they will just clear the filter. Okay, got it? Because it's solid, it is not dissolved in water, so you can see it. Okay, so most of the solid material is blocked at the first filter, they call it the bar screen. Okay, then we have then from there it can go to a grid tank. A grid tank is also a sort of a natural filter. Okay, so you put some stones, okay, a stone bed or a soil bed, okay, a layer of stone or soil, and then you pour water on it. What will happen? In between the soil and the stone, the water will pass, right? And the solid, it will remain on the layer. It will not pass from the pores, right? The gap, it will not pass from the gaps. Okay, so this is what we call as a grid tank. Okay, so the grid tank has a layer of soil or stones. It lets the water pass and the solid are remaining on top of the layer. Got it? Okay, then we have the settling tank. Okay, in the settling tank you let the water go slowly, so the small particles, they settle. Okay, they will settle at the bottom of the tank. Okay, so the water is collected from the top and the solid particles are settled on the at the bottom of the tank. Okay, so it's reverse process. Here you are taking the water from the under the layer, right? Here the water is going from the top and the particles are settling. Okay, so when the water is going slowly, the small particles, they have a chance to settle, so they will just go to the bottom of the tank, and the pure water or the cleaner water will be taken from the top. Okay, so that is called as a settling tank. Then we have a digester. Okay, so in this now you apply some sort of heating, boiling, okay, of the water again to get rid of the extra materials. Okay, so the whatever chemicals you want to burn, it will burn here. Okay, so we call it a digester. Okay, some part of the water may go to an aerator as well. What is an aerator? It's a tank again. So you have the water, and in water you throw some oxygen. You pump oxygen into water. This is what we call as aeration. Aeration means what? Pumping oxygen in water. Okay, what will oxygen do? What will oxygen do in water? Anyone? Nothing? It will start, it will make the decomposition of organic matter faster. Okay, oxygen is like a catalyst. Okay, it's like an accelerator. Okay, so when organic material has more oxygen, it will decompose faster. So if it was supposed to decompose in 1 week, with more oxygen, it will decompose in few hours. Okay, so you are getting rid of organic material here. Then it will go to the clarifier again. In the clarifier, now you are taking the decomposed organic material out now. So it's again like a filter, small filter. Okay, and then from there you can again do some extra treatment with UV light, radiation again to kill the chemicals now. Any harmful chemical, you want to burn it, destroy it, so then you can do it like this as well. And after all this, you can throw the water back into the water body, back into your supply. Now you can use it or whatever. And all the material which you have collected, it will go to some other disposal site. You collected some solids, right? So these solids can also be recycled. It can be reused or they can be disposed. That's another process. Okay, the last thing is geomatics and remote sensing, something related to surveying, right? Already taking surveying, right? All of you have taken surveying. Okay, so what is geomatics? It's a science and technology dealing with earth measurement. The term geo means earth. Geo means earth. Matic means measurement. Okay, matic means what? Measurement. So geomatic means what? Measurement of earth. Okay, so obviously it's a big science. It's a big science. Not everybody can understand it. A lot of people take F's and so on, right? Dr. Nidal is world famous in his F's. Okay, so it includes data collection. Data collection can be done through field surveying. So you can actually go to the field and collect data, what you have all done in your surveying course. So you may have used some of these equipments, right? Which of them have you used? Tell me. Total station you have used. Okay, which other equipment? Theodolite you have used. Okay. Any other equipment which is not written here and you have used? There was one equipment which is not written here, but you may have used it. You won't remember anything from surveying? You passed the course. Okay. There was something for measuring elevations, right? You call it what? How do you measure elevations? Huh? Yeah. So there's a level, automatic level or digital level or something like this. Okay. So these are field techniques. You have to go to the field, right? You have to go to the field to collect the data. And then we have remote sensing technique. Remote sensing means what? I collect the data without going in the field. Fun, right? No going in the field. That's why we don't teach you that. Okay? You don't want any fun. So you can collect data through aerial photography, photographs taken from airplanes or buildings and so on. Okay? Or satellite images, satellite maps, Google Earth, Google Map. Okay? Things like that. You still have the data, right? You have the map, you have the data. Okay. Another thing which is not mentioned here, they use it in other countries. It is illegal to use it here, but drone. Okay. Drone technology is also used for remote sensing. Okay. Once you collect the data from any of these things, then you process the data, and now the processing is all done through computer programs. Okay. So we have AutoCAD, for example. AutoCAD can process this data. Then you represent the data in form of maps. Okay, so these are the three main steps related to geomatics. Collecting the data. Data can be collected on field or through remote sensing. Then processing the data and then preparing the map. Okay, so the calculations you were doing in surveying, they were data processing. Okay, so you collected the data using these equipments, then you process the data, and you may have prepared the maps as well, I don't know. Then we have remote sensing. Remote sensing is mentioned here, right? Remote sensing is used for what? It is used for what? Collecting the data. Okay, so it's a method of collecting the data. Okay, using some image or photograph. Okay, something in which you don't go in the field. Okay. Yeah, so now we have satellites available which are doing this for us continuously. There are satellites available all around the earth which are collecting data using different type of sensors. So they are not only taking photographs, they are not only taking images. Some of them are using radar sensors or LiDAR sensors or heat sensors, thermal sensors, different types of sensors. Okay, for example, there are satellites which are collecting earthquake data, so they are using thermal sensors or thermal sensors like this. Okay, so Obviously, the data collected through these sensors has much more application, is much more convenient to use as compared to the normal photographs which we used to have earlier. Okay, so this one is more efficient and more useful. Clear? Okay. So which topic are you doing? Okay, and you guys?